In 1642, in a small village in rural England, a baby boy was born. His name was Isaac, and he would go on to change the world. But as he lay in the cradle, no one could have guessed the extraordinary journey that lay ahead of him. You see, Isaac's dad had passed away before he was even born. And his mom, well, let's just say she wasn't exactly what you'd call warm and fuzzy. But young Isaac had a big advantage over most kids his age. You see, Isaac was born with something called natural scientific curiosity. We all have it to some extent. It's that thing that makes us question how things work, why things happen. But Isaac, well, he took it to a whole different level. Dive into the early life of Isaac Newton, exploring the events and discoveries that shaped one of history's greatest minds. So sit back, grab your popcorn, and join me as we explore the fascinating origins of one of history's greatest minds. The story of Sir Isaac Newton. Isaac Newton was born in Woolsthorpe, a village nestled in the picturesque Lincolnshire wolds. These rolling hills, dotted with quaint thatched cottages and ancient churches, were the backdrop of Isaac's early years. Imagine the tranquility of this setting, the wide open spaces, the babbling brooks, and the starry nights. It was here, amidst this idyllic landscape, that Isaac began his journey into the world. But don't be fooled by the peaceful surroundings, because Isaac's childhood wasn't all that serene. You see, his dad died before Isaac was even born, leaving his mom, Hannah, to raise him and his younger brother alone. And let me tell you, Hannah wasn't exactly what you'd call a natural at the whole parenting thing. She was strict, distant, and not really good with emotions. So young Isaac spent much of his early childhood feeling unloved and misunderstood. But being an only child, albeit an older one, also meant that he got a lot of time to himself, which he spent exploring the world around him, discovering all sorts of interesting things that piqued his curiosity. One of his favorite things to do was play with lenses. You know, those things that bend light and make things look bigger or smaller, or all funny and distorted. He loved to experiment with them, seeing what kind of images they made, how they worked, and all the cool stuff you could do with them. He was also fascinated by light and color and how they interacted. He'd spend hours just looking at things, trying to figure out what made them look the way they did. He also loved tinkering with mechanical devices, taking things apart and putting them back together again, just to see how they worked. He was always curious about how things worked, why they happened the way they did, and what would happen if he changed things. You know, like what would happen if a cannonball were dropped from a certain height, or how long it would take for a ball to roll down a set of stairs. He was constantly asking questions and trying to figure things out. And as he grew older, his curiosity only intensified. He devoured books on math, physics, and astronomy, and he began to develop his own theories about how the world worked. Now, you might be thinking, okay, so this guy's got a lot of interests, but what does that mean? Well, it means that when Isaac started school, he didn't fit in very well. I mean, sure, he was smart and all that, but he wasn't interested in the same things as the other kids. They wanted to talk about sports and girls and all that, but Isaac wanted to talk about, well, you know, the secrets of the universe. So he often felt isolated and misunderstood, like he just didn't belong. When Isaac was 12 years old, his mother remarried a man named Nicholas Custis, who became Isaac's stepfather. And while he wasn't as bad as some stepfathers, he certainly wasn't Mr. Perfect either. Custis thought Isaac was a bit odd and not really worth his time. Plus, he had his own kids from his previous marriage who were, you guessed it, a lot more interested in sports than science. So Isaac spent even more time on his own, exploring his interests and developing his love for learning. But eventually, his mother realized that Isaac needed some guidance and enrolled him in a local grammar school. There he learned Latin and Greek and all the classics, but he wasn't really interested in them. He much preferred spending his time reading books on math, physics, and astronomy. Despite his interests, Isaac wasn't really a bookworm. He liked to learn by doing, by experimenting and discovering things for himself. In fact, He was a bit of a prankster and often got into trouble for, well, let's just say his experiments didn't always go as planned. When he was 14, his mother sent him to live with his maternal grandfather, who had a farm in the village of Great Ayton. But it turned out that living on a farm wasn't exactly his calling. I mean, sure, there were some cool things about it, like working with animals and all that. But overall, it just wasn't really his thing. Fortunately, Isaac's mom saw that farming was unreally his thing and decided to send him to Trinity College, Cambridge in 1661. And let me tell you, Isaac was in his element. Finally, he was in an environment where he could explore his interests and learn from some of the brightest minds in the country. When he arrived at Trinity, Isaac was just 17 years old. But don't let that fool you. He was already a force to be reckoned with. You see, Isaac had a natural talent for mathematics and physics. He was one of those people who just had a knack for it. He could grasp complex concepts easily, and he had a unique way of thinking about things that allowed him to see solutions that others couldn't. But it wasn't just his intelligence that made Isaac stand out. It was also his sheer determination and work ethic. While most students were content with just scraping by, Isaac was always striving to excel. He threw himself into his studies, poring over books, working through complex problems, and challenging the status quo. And it didn't take long for his professors to notice his brilliance. They began giving him special assignments and asking him to help with their research, and Isaac thrived in this environment. Now, you might be thinking, okay, so he's smart and hardworking. Who doesn't love a good success story? Well, here's the thing. Isaac had something else going for him that made him truly unique: his insatiable curiosity. You see, Isaac wasn't satisfied with just memorizing facts and figures and regurgitating them on exams. He wanted to understand the underlying principles that governed the world around him. He asked endless questions, always seeking to dig deeper and learn more. And this insatiable curiosity would become the driving force behind many of his greatest discoveries. But within only a few years, he would become one of the most important figures in the history of science. The year is 1666, and the plague has just reached Cambridge, forcing Isaac to return home to Woolsthorpe Manor. And while everyone else is running away from the plague, Isaac decides to stay in his room and conduct experiments. And it's there that he has a revelation that will change the world forever. While sitting under an apple tree, he sees an apple fall to the ground, and he asks himself, why don't apples fall up? Why do they fall down? This seemingly simple question leads him to one of the most important discoveries in the history of science: gravity. He starts experimenting by rolling balls down inclines and discovers that all objects accelerate towards the ground at the same rate regardless of their mass. He then generalizes this concept and realizes that the Earth must be pulling all objects towards its center. But why? What is the nature of this force? To answer that, he imagines placing a cannonball on the surface of the Earth and then firing it straight up. If he could fire the ball with sufficient speed, it would reach a very high altitude before slowing down and eventually falling back to the ground. But how fast exactly would the ball need to be fired? Newton calculates that the ball would need to be fired at around 11 kilometers per second, which is around 40 times the speed of sound. But in reality, it's impossible to fire a cannonball that fast. So instead, he considers what would happen if the ball was fired into space. If there were no air resistance, the ball would never fall back to Earth. It would simply drift off into space. Therefore, there must be some force preventing it from going into space, and that force is gravity. He realizes that the strength of gravity depends on the mass of the object and the distance between the objects. For example, if the cannonball was twice as massive, it would experience twice as much gravitational force. And if it was twice as far away from the Earth, it would experience half as much gravitational force. These ideas lead him to develop his law of universal gravitation, which states that every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This discovery not only revolutionizes our understanding of the physical world, but also provides a mathematical framework for describing the motion of celestial bodies. With this new understanding of gravity, Newton was now able to explain the motion of planets around the Sun. By applying the laws of motion and calculus to these calculations, Newton realized that each planet's orbital path is an ellipse with the Sun at one focus. He also discovered that a planet's orbital period squared is proportional to the semi-major axis of its orbit cubed. In other words, the farther a planet is from the Sun, the longer it takes to orbit. These discoveries are summarized in his book, Philosophiae Naturalis Principia Mathematica, published in 1687. This groundbreaking work establishes Newton as one of the most important figures in the scientific revolution and lays the foundation for classical mechanics. His work also helps to usher in a new era of scientific thinking based on observation, experimentation, and mathematical analysis rather than relying on the ideas of ancient authorities like Aristotle. But Newton's genius is not limited to just one field. His work in mathematics is equally revolutionary. He independently develops the calculus, a branch of mathematics that deals with rates of change and accumulation, along with Gottfried Wilhelm Leibniz. Calculus provides the language and tools for describing many natural phenomena such as motion, forces, and energy, which helps to further advance scientific knowledge in various fields. In 1672, Newton becomes Warden of the Mint and moves to London. In this role, he works to improve the English currency system and combat counterfeiting. While this job might seem like a demotion from a scientific perspective, it actually turns out to be a great opportunity for Newton. Not only does he get to work on interesting engineering problems, but he also has access to a steady income and doesn't have to worry about funding his research anymore. He uses this newfound financial stability to purchase a house and finally move out of his lodgings at Trinity. He furnished his house with a collection of art, bric-a-brac, and domestic animals. But despite his comfortable living situation, Newton remains a bachelor throughout his life. Some speculate that he was never married because he never found the right woman. Others suggest that his relationship with his mother was so bad that he simply didn't want to live with a woman. Whatever the reason, Newton never marries and his domestic life is largely uneventful. Throughout his career, Newton serves as both warden and master of the mint, playing a key role in shaping England's economic policy. But his responsibilities don't end there. In 1696, he is elected to Parliament and represents Cambridge University until 1701, while serving as MP. Newton plays an active role in debates over issues such as currency reform and the Bank of England. Though he never holds an academic position after leaving Cambridge, Newton continues to be involved in the intellectual life of the university. He delivers lectures and supervises graduate students, helping to train the next generation of scientists and scholars. Despite his many responsibilities and accomplishments, Newton's health begins to decline in his later years. He suffers from declining eyesight, which makes it difficult for him to continue his scientific work. However, undeterred by this setback, Newton continued working until the end of his life. In 1703, Newton is knighted by Queen Anne and becomes Sir Isaac Newton. 4 years later, he is appointed to the newly created position of Lucasian Professor of Mathematics at Cambridge, a role he had previously held before leaving for London. He returns to Cambridge and gives the Lucasian chair a much higher profile through his public lectures on optics and other subjects. Newton continues to make significant contributions to the field of mathematics, publishing several papers on the subject. One of his most notable works in this area is De Methodis Inventa, in which he describes his invention of calculus and explains its applications in solving various problems. However, Newton's work in mathematics is not without controversy. His methods and results are often challenged by other mathematicians of the time, leading to a series of public disputes and debates. Newton's prickly personality and unwillingness to compromise or share credit for his discoveries contribute to the animosity among scientists, making collaboration and progress in the field more difficult. For example, his feud with the mathematician Gottfried Wilhelm Leibniz over the invention of calculus creates a bitter rivalry that hinders the development of the field for decades. Newton's work in optics is another area where he faces criticism and opposition. His ideas on the nature of light and color are seen as heretical by some, and he is mocked by his peers for his belief that white light is composed of all colors of the rainbow. However, Newton's experiments with prisms and colored glass demonstrate that white light can be split into its component colors and recombined to form a spectrum. He also proposes a theory of color vision based on the idea that different colors of light stimulate different receptors in the eye, allowing us to perceive a wide range of colors. Although his theory of color vision is not widely accepted during his lifetime, his work in optics lays the foundation for future discoveries in the field and helps to establish him as one of the most important scientists of the age. Sir Isaac Newton died on March 31, 1727, leaving behind a legacy that would change the world forever. His contributions to mathematics, physics, and astronomy are monumental and have had a profound impact on the course of scientific development. Newton's laws of motion and universal gravitation revolutionized the way we understand the universe, explaining the motion of planets and other celestial bodies with unprecedented accuracy. He also made significant contributions to mathematics, independently developing calculus, a branch of mathematics that deals with rates of change and accumulation. His work in optics was equally groundbreaking, demonstrating that white light is composed of all colors of the rainbow and proposing a theory of color vision that laid the foundation for future discoveries in the field. Newton's impact on science and mathematics is immeasurable, and his legacy continues to inspire scientists and thinkers today. His dedication to knowledge, curiosity, and pursuit of understanding the world around us serves as a guiding light for those seeking to make their own contributions to the advancement of science. As one of the greatest minds in the history of science, Newton's discoveries laid the foundation for modern physics and mathematics, shaping our understanding of the universe and inspiring future generations of scientists to reach new heights in their own discoveries. Inspired by the genius of Isaac Newton. Hit like if you enjoyed this journey, share with friends who love history, and subscribe to explore more stories of the world's greatest minds.